You have probably seen the video circulating online claiming that Toyota secretly moved back to 5W-30 motor oil because thin oils like 0W-20 were destroying engines. The video says there is a technical service bulletin from 2026 that proves Toyota admitted they were wrong about thin oils. The claim spread like wildfire across car forums, with thousands of owners wondering if they should dump their 0W-20 oil and switch to 5W-30 immediately to save their engines. But here's what nobody is telling you. The entire claim is based on a complete misunderstanding of what Toyota actually said in their service bulletins, and following this advice could actually void your warranty and harm your engine. Let us begin by reviewing what is going on here. A popular expert mechanic named Scotty Kilmer posted a video claiming Toyota issued a technical service bulletin that quietly switched all 2026 and newer vehicles back to 5W-30 oil. According to the video, Toyota realized that 0W-20 and 0W-16 oils were too thin and caused engines to burn excessive oil, leading to failures. This claim spread rapidly through Toyota owner forums. On Toyota Nation, one user summarized the video and stated he was seriously considering switching his 2021 Highlander to 5W-30 based on what he heard. Other forum members immediately checked their 2026 Highlander owners' manuals and found something interesting. Toyota still recommended 0W-20 for those engines. There was no mention of 5W-30 being the new standard. Forum members started digging deeper, searching for the alleged technical service bulletin that supposedly proved the switch. They could not find it. Multiple threads on Bob is the Oil Guy, Ranger 5G, and RAV4 World forums showed the same pattern. Enthusiasts searched Toyota's technical service bulletin databases and found absolutely no bulletin from 2026 instructing dealers to switch from thin oils to 5W-30 across the board. So what is actually in these Toyota technical service bulletins? In 2013, Toyota issued a technical tip document numbered TTT026213 titled Oil Viscosity, Applicability, and Change Interval Guide. The document covered 2010 through 2014 Toyota models and explained Toyota's transition strategy. The bulletin clearly stated that starting with the 2010 model year, Toyota began a gradual transition to synthetic 0W-20 oil, specifically because it reduces friction and wear, improves fuel economy, reduces waste oil, and allows 10,000-mile oil change intervals. The document emphasized that this was a deliberate engineering decision based on extensive testing. It noted that vehicles for which 0W-20 was optional, compared to 5W-20 or 5W-30, must still follow shorter 5,000-mile intervals, but the goal was to move the entire fleet toward thinner synthetic oils. The table in that bulletin showed that some 2010 through 2012 engines, like the two GRFE used in the RAV4 and Sienna, still specified 5W-30, but later model years of those same engines switched to 0W-20. The trend through the 2010s was clearly toward thinner oils, not thicker ones. This bulletin shows that Toyota was moving away from 5W-30 by design, not reluctantly returning to it. There is a technical service bulletin, TSB 010421, issued in December 2021. This is one of the bulletins people misunderstood and assumed supported the 5W-30 switch claim. The bulletin was titled Malfunction Indicator Light On with Low Oil Pressure Diagnostic Trouble Codes and Milky or Discolored Engine Oil. It addressed complaints in 2018 through 2022. Toyota models equipped with A25A FKS, A25A FXS, or M20A FKS engines. Owners reported low oil pressure warnings and noticed their oil looked milky or discolored. Toyota investigated and determined the condition was caused by moisture condensing inside the engine oil during short trips in freezing temperatures. When an engine does not fully warm up, water vapor from combustion can condense in the crankcase and mix with the oil, creating that milky appearance. The repair procedure in this bulletin instructed technicians to inspect the oil, drain it completely, replace the oil filter, and refill with API SN RC0W16 oil. Read that again. The bulletin specifically said to use 0W16 oil, not 5W-30. It emphasized that the recommended viscosity was still 0W16 and referred technicians to the owner's manual for the correct oil grade. This bulletin actually reinforces that Toyota wants thin oil in these engines. It does not advocate switching to 5W-30 at all. Toyota updated that bulletin in February 2024 with revision 2. The updated version expanded model year coverage to 2018 through 2024 vehicles, but did not change anything about the recommended oil viscosity. It continued to specify 0W16 for gasoline engines and 0W8 for some hybrid powertrains. The revision urged technicians to follow the owner's manual specifications precisely. There was absolutely no hint anywhere in this bulletin or its revision that Toyota moved back to 5W-30. In fact, the bulletin went even thinner by specifying 0W8 for certain applications. Now, another bulletin that gets mentioned is Technical Service Bulletin TSB 003015 from 2015. That bulletin dealt with oil consumption in certain 2006 through 2013 vehicles with the 2AZFE engine. It superseded an earlier 2011 version and instructed technicians how to measure oil consumption and replace pistons and rings if consumption exceeded Toyota standards. The parts list in that bulletin included 0W20 or 5W20 oil for the repair procedure. Notice it did not recommend switching to 5W30 as a solution to oil consumption. It specified using the originally recommended oils and focused entirely on mechanical repair of worn components. If Toyota believed thicker oil was the answer to consumption problems, this would have been the perfect bulletin to say so. They did not. Public technical service bulletin databases maintained by the National Highway Traffic Safety Administration and by various automotive aggregator websites contain thousands of Toyota bulletins. Independent researchers and forum enthusiasts searched these databases extensively looking for any bulletin issued between 2021 and 2026 that revised oil recommendations for the A25A, M20A, or other mainstream Toyota engines from 0W20 or 0W16 to 5W30. Not a single bulletin was found. The only Toyota technical service bulletins that reference 5W30 as a primary recommendation are older documents from the early 2010s, covering engines like 2GRFE, 1GRFE, or 3RFE. Those were engines designed before the thin oil transition. Additionally, some heavy-duty truck applications still use 5W30, but that has always been the case for commercial vehicles. Enthusiasts also examined the 2024 through 2026 owner's manuals for popular Toyota models, including the Highlander, Camry, Corolla, and RAV4. Every single manual continues to specify 0W20 or 0W16 as the primary recommended motor oil. Some manuals mention that 5W20 or 5W30 can be used temporarily if the recommended oil is unavailable, but they explicitly state this is only for emergency situations until you can obtain the correct viscosity. No manual instructs owners to permanently switch to 5W30. This is critical because the owner's manual represents the legal specification for warranty purposes. If Toyota had genuinely moved back to 5W30, they would have updated these manuals immediately. They have not. Now, the idea that thin oils cause excessive oil consumption is not just wrong, it fundamentally misunderstands how modern engines work. Modern engines are not the same as engines from the 1980s or 1990s. The internal architecture has changed dramatically. Corporate average fuel economy regulations, spelled CAFE, have forced manufacturers to extract every possible efficiency gain from their powertrains. One of the most effective ways to improve fuel economy is to reduce internal friction in the engine. Thicker oils create more resistance as the crankshaft spins through the oil and as the oil is pumped through passages. That resistance wastes energy. Thin oils like 0W20 or 0W16 flow more easily, reducing pumping losses and friction losses. Independent testing shows that switching from 5W-30 to 0W-20 can improve fuel economy by 1 to 2%. That might not sound like much, but across millions of vehicles and billions of miles driven, it adds up to massive fuel savings and emissions reductions. But fuel economy is only part of the story. Modern engines have extremely tight machining tolerances compared to older designs. The oil passages inside the engine block are much narrower. The bearing clearances between moving parts are measured in thousandths of an inch. If you try to force a thick oil like 5W-30 through these tiny passages, especially during cold startup, the oil cannot flow fast enough. Parts that need lubrication might not get it immediately. This is particularly critical for components like variable valve timing actuators and turbocharger bearings that require instant oil flow to prevent wear. A detailed engineering article from Heavy Vehicle Inspection explains that modern engines with these narrow passages can actually be starved of lubrication if the oil is too thick. The article notes that 0W16 and even 0W8 oils are specifically engineered to flow quickly through these restricted pathways. The materials and coatings used in modern engines have also evolved. Technologies such as diamond-like carbon coatings and low-friction piston rings allow thin oils to provide sufficient film strength to prevent metal-to-metal contact. These coatings are so effective that they actually work better with thin oils because the thinner oil can get into microscopic surface irregularities more easily. The additive packages in modern motor oils meeting APISP and IL SACGF6 standards have improved dramatically. These additives maintain film integrity even at high temperatures, resist oxidation, and provide superior detergency to keep pistons and rings clean. A thin oil with a modern additive package provides better protection than an old formulation thick oil. The piston rings in modern engines also use different designs than older engines. Low-tension piston rings reduce friction drag, but they require oil that flows easily to maintain the seal. If you use oil that is too thick, it can actually interfere with ring sealing, because it does not drain away from the ring lands quickly enough. This can lead to oil consumption problems and carbon buildup, the exact opposite of what people think thick oil will prevent. Castrol's educational materials explain that motor oil viscosity numbers represent the oil's flow characteristics at cold and hot temperatures. The first number before the W indicates how the oil flows at cold startup. A lower number means the oil remains fluid at lower temperatures, ensuring it reaches critical engine parts immediately when you start the car. This reduces wear during cold starts, which is when most engine wear occurs. The second number indicates the oil's thickness at operating temperature. Modern engines with tight tolerances are designed around specific operating viscosities. Using a thicker oil than specified can reduce fuel economy by 2 to 4%, increase emissions, and potentially void the warranty. Here is a statistic that should make you think. More than 70% of new vehicles sold in 2024 specify 0W20 or thinner oils as their primary recommendation. By 2030, industry analysts predict that 0W16 or 0W8 will become the standard for most passenger vehicles. This is not happening because manufacturers are cutting corners. It is happening because engine technology has advanced to the point where these thin oils provide superior protection and performance. Toyota is following the same engineering path as every other major automaker. Honda, General Motors, Ford, Volkswagen, Hyundai, and virtually every manufacturer have moved toward thinner oils for their modern engines. Let's address the specific concern about oil consumption that drives much of the fear around thin oils. Some Toyota engines, particularly the two AZFE engines used in certain Camry and RAV4 models, did have oil consumption issues. This is well documented. Toyota determined through extensive investigation that the consumption was caused by defective piston ring designs and inadequate ring seating during manufacturing, not by oil viscosity. The Technical Service Bulletin addressing the two AZFE consumption instructs dealers to replace the pistons and rings with updated parts. The bulletin continues to specify 0W20 or 5W20 oil after the repair. If thin oil caused the consumption, Toyota would have simply told dealers to switch to 5W-30 and save the cost of mechanical repairs. They did not do that because the oil was not the problem. The faulty hardware was the problem. Toyota's confidence in thin oils is further demonstrated by their extended oil change intervals. For vehicles that require 0W20 synthetic oil, Toyota recommends 10,000-mile oil change intervals under normal driving conditions. Would they extend change intervals if they thought the oil was inadequate? Absolutely not. They have tested these oils extensively under severe conditions and determined that they maintain their protective properties for 10,000 miles. Meanwhile, vehicles that still use 5W-30 typically require 5,000-mile oil change intervals. The thin oils actually last longer because they resist thermal breakdown and oxidation better than conventional thick oils. When forum members actually investigated the claim, several went to local Toyota dealers and asked service advisors about the alleged switch to 5W-30. Every dealer confirmed that there was no such bulletin and that 0W20 or 0W16 remained the specified oil for modern Toyota engines. One forum member posted a photo of his 2026 Highlander owner manual open to the lubrication specifications page. It clearly stated 0W20 as the recommended viscosity. Another member called Toyota Corporate Customer Service and asked directly if there had been any change to oil recommendations. The customer service representative checked internal systems and confirmed no change had occurred. The representative specifically noted that if such a major revision had been issued, it would be prominently featured in service bulletins and owner communications. It was not. These on-the-ground checks all confirmed the same thing. Other forum members pointed out the logical flaws in the claim. If Toyota had genuinely discovered that thin oils were destroying engines, they would face massive liability issues. Every vehicle sold from 2010 to 2026 with a thin oil recommendation could potentially have a defective lubrication specification. The legal and financial implications would be enormous. Toyota would have to issue a massive recall or at minimum a widespread service campaign. There would be technical service bulletins, dealer notifications, and owner mailings. None of that happened. What did happen is that Toyota continued to specify thin oils, continued to extend oil change intervals, and continued to offer industry-leading powertrain warranties. Does that sound like a company that discovered their oil specifications were destroying engines? Some defenders of the thick oil theory argue that Toyota is hiding the problem to avoid recall costs. This conspiracy theory does not hold up to scrutiny. Technical service bulletins are public documents. Dealerships receive them electronically and they are archived in multiple databases. Reporters, consumer advocacy groups, and independent mechanics all have access to these bulletins. If Toyota issued a bulletin switching to 5W-30, it would be impossible to hide. Moreover, Toyota has been transparent about actual problems in the past. When they had unintended acceleration issues, floor mat interference problems, or frame rust concerns, they issued recalls and technical service bulletins. They did not try to hide those problems because hiding them would have been impossible and would have made the liability worse. There is no evidence of any cover-up regarding motor oil specifications. What happened is that Toyota transitioned most of their engine lineup from 5W-30 to 0W-20 between 2010 and 2015. This was deliberate and based on extensive engineering validation. A few older engine designs continued to use 5W-30 because they were designed before the thin oil transition, and their internal tolerances were not optimized for thinner viscosities. Some heavy-duty applications also continue to use 5W-30 for valid engineering reasons. But the mainstream passenger car and light truck engines, which represent the vast majority of Toyota's production, specify 0W-20 or 0W-16. This has been consistent policy since the mid-2010s and shows no signs of changing. Here is what you need to understand about your specific vehicle. The oil viscosity specified in your owner's manual was determined through hundreds of hours of durability testing. Toyota engineers ran engines on dynamometers, simulating hundreds of thousands of miles under various load and temperature conditions. They measured wear on bearings, camshafts, pistons, and cylinder walls. They tested fuel economy, emissions, and cold start performance. The viscosity recommendation in your manual represents the optimal balance of all these factors for your specific engine design. When you use a different viscosity, you are substituting your guess for their tested engineering data. Using a thicker oil than specified can cause several problems. First, it increases internal friction, which reduces fuel economy and increases emissions. Your engine has to work harder to spin the crankshaft through thicker oil and to pump that oil through narrow passages. Second, thick oil may not flow quickly enough during cold starts. The first few seconds after starting your engine are when most wear occurs because oil pressure has not yet built up fully. Thin oil reaches critical components faster. Third, thick oil may not drain away from certain areas as designed. Oil needs to return to the pan so the pump can recirculate it. If oil puddles in the cylinder head or around the rings because it is too thick to drain properly, it can cause consumption and carbon deposits. Using a thinner oil than specified can also cause problems. If the oil is too thin, it may not maintain adequate film strength between moving parts under high loads or high temperatures. The oil film could break down, allowing metal-to-metal contact. However, this is only a concern if you go significantly thinner than recommended. The difference between 0W20 and 0W16 is minimal in terms of high-temperature protection. Both meet stringent standards for film strength. The difference between 0W20 and 0W8 is larger, which is why 0W8 is only specified for certain hybrid engines that operate under different thermal conditions. The key point is this: use the viscosity specified in your owner's manual. If your manual says 0W20, use 0W20. If it says 0W16, use 0W16. If your vehicle is old enough that the manual specifies 5W-30, use 5W-30. Do not switch based on internet videos or anecdotal advice. The manual represents the manufacturer's engineering specification and is what your warranty coverage is based upon. If you use a non-specified oil and have an engine problem, the manufacturer can and will deny warranty coverage on the grounds that you did not maintain the vehicle according to specifications. If you are concerned about oil consumption in your Toyota, the correct approach is to monitor your oil level regularly. Check it every 1,000 miles or before long trips. If consumption exceeds 1 quart per 1,000 miles, that is considered excessive, and you should have the vehicle inspected by a dealer. Toyota may perform an oil consumption test where they measure exactly how much oil the engine uses over a specified mileage interval. If consumption exceeds Toyota's internal standard, which is typically 1 quart per 1,200 miles, they may approve warranty repair. That repair will involve inspecting the piston rings, valve seals, and PCV system. It will not involve changing the oil viscosity. Some Toyota models have extended warranty coverage for oil consumption issues. For example, certain 2 AZFE engines built between 2006 and 2011 have an 8-year unlimited mileage warranty extension covering excessive oil consumption. If your vehicle falls under such a program, Toyota will repair it at no cost, but only if you have maintained the vehicle according to specifications, which means using the correct oil viscosity. Let's address one more common question. What if 0W20 is not available when you need an oil change? This can happen occasionally, especially with newer viscosities like 0W16. Most Toyota owners' manuals include a viscosity chart that shows temporary substitutes. For engines specifying 0W20, the manual typically allows 5W20 as a temporary replacement until the next oil change. Some manuals allow 5W-30 if both 0W20 and 5W20 are unavailable, but again, this is temporary. You should switch back to the specified viscosity as soon as possible. The manual makes clear these are emergency measures, not permanent alternatives. Why does Toyota allow these temporary substitutes? If viscosity is so critical, because it is better to have any oil than no oil. If you are on a road trip in a remote area and your oil level is low, adding 5W-30 is better than driving with low oil level and risking catastrophic damage. But that does not mean 5W-30 is equivalent to 0W-20. It means that short-term use of a substitute is less harmful than running low on oil. Once you return home, you should have the oil changed to the correct specification. You might wonder if oil consumption will be lower with 5W-30 than with 0W-20. In engines designed for 0W-20, the answer is usually no. Remember that ring seal depends on proper oil drainage and oil control ring tension. These factors are optimized for the specified viscosity. Using thicker oil might slightly reduce consumption in an engine with worn rings because the thicker oil partially compensates for excessive clearances, but that is a band-aid, not a fix. The correct solution is to repair the worn components. Also, thick oil can cause other forms of consumption. If oil does not drain away from the cylinder head efficiently, it can be drawn past the valve seals into the combustion chamber. Or if oil pools around the rings, it can be scraped into the combustion chamber during the intake stroke. Oil consumption is a complex issue, and changing viscosity rarely solves it without side effects. What about older Toyota engines that originally specified 5W-30? Should you switch those to 0W-20 to get modern benefits? Generally, no. If your engine was designed for 5W-30, its bearing clearances and oil passages were sized for that viscosity. Switching to a thinner oil could reduce oil pressure and film strength below safe levels. Your oil pressure gauge might show lower readings. In severe cases, you could accelerate bearing wear. The one exception might be if Toyota later revised the specification. Some engines had their recommended viscosity changed via service bulletin as manufacturing tolerances improved over the production run. Check your owner's manual and any applicable service bulletins for your specific model year. If the specification changed, follow the updated specification. If it did not, stick with the original. Another scenario to consider is extreme climates. If you live in an extremely cold region, 0W-20 and 0W-16 provide excellent cold start protection. The 0W rating means the oil remains fluid down to very low temperatures. This is actually an advantage of thin oils. They protect your engine better during winter starts than 5W-30 would. Conversely, if you live in an extremely hot climate or do extensive towing or racing, you might worry that thin oil cannot handle the heat. This concern is addressed by modern additive packages. 0W-20 oils meeting current specifications maintain their film strength at high temperatures, as well as older 5W-30 formulations. The second number in the viscosity rating, the 20, indicates the oil's thickness at operating temperature. A 0W-20 and a 5W-20 have the same high temperature viscosity. They only differ in cold flow properties. For severe duty use, such as extensive trailer towing or track driving, some manufacturers do recommend specific oil grades. Check your owner's manual for any severe service recommendations. Some Toyota trucks, when towing heavy loads, may call for 5W-30 or even 5W-40 under extreme conditions. This is clearly specified in the manual under special operating conditions. It is not a blanket change for all driving. Toyota issued no technical service bulletin in 2026 or any recent year instructing dealers to switch modern engines from 0W-20 or 0W-16 back to 5W-30. The bulletins addressing oil pressure and oil consumption issues continue to specify thin oils and focus on mechanical repairs when problems occur. The trend across Toyota's engine lineup since 2010 has been consistently toward thinner synthetic oils, not back toward thicker oils. Current owner's manuals for 2024 through 2026 models specify 0W-20 or 0W-16 for the vast majority of engines. Forum members, dealership service advisors, and independent researchers have all confirmed there is no 5W-30 switch. Automotive engineering sources explain that modern engines require thin oils due to tight tolerances, advanced materials, and efficiency demands. For owners wondering what to do, the answer is simple. Open your owner's manual and look at the lubrication specifications page. Use the oil viscosity listed there. For most Toyota vehicles built after 2015, this will be 0W-20. For some newer models, particularly hybrids, it may be 0W-16 or even 0W-8. For older vehicles or specific truck models, it may still be 5W-30 or 5W-40. Whatever your manual says, that is what you should use. Buy oil that meets the API and ILSAC specifications listed in your manual. Change it at the intervals your manual specifies. Check the level regularly and top it up if needed with the same viscosity. If you experience excessive consumption defined as more than 1 quart per 1,000 miles, document it and take the vehicle to a dealer for evaluation. If you want to dive deeper into this topic, understand a bit about how oil specifications work. The American Petroleum Institute assigns performance ratings to motor oils. The current gasoline engine rating is SP, which superseded SN in 2020. Oils meeting SP standards have improved protection against low-speed pre-ignition, better oxidation resistance, and enhanced wear protection. The International Lubricant Standardization and Approval Committee, which works with automakers, uses a parallel specification called ILSAC-GF6. Oils meeting GF6 are backward compatible with earlier GF5 specifications and provide fuel economy benefits. Your Toyota manual will specify what API and ILSAC ratings are required. Use oil meeting those specifications regardless of viscosity. Oil brands matter less than specifications, but quality does matter. Major brands like Mobil 1, Castrol, Pennzoil, Valvoline, and Toyota Genuine Oil all produce excellent products meeting current specifications. Some people swear by synthetic oil, while others use synthetic blends or conventional oil. For most modern Toyota engines specifying 0W20, full synthetic is essentially required because conventional oil cannot meet the flow and protection requirements at that viscosity. You may pay a bit more for synthetic, but you get better protection and can run the full 10,000-mile change interval that saves you money over time. Oil filters also deserve attention. Toyota Genuine filters are excellent and relatively affordable. Independent brands like Wix, Purolator, and Fram also make quality filters. Avoid the cheapest no-name filters because they may use inferior filter media or weak construction that can fail. A good filter should trap particles down to 20 to 30 microns and should have a robust anti-drain back valve so oil does not drain away from the engine when parked. Change the filter every time you change the oil. Never reuse an old filter. Some people notice that 0W20 oil appears thinner when you pour it compared to 5W30, and they assume this means less protection. What you are seeing is cold viscosity. At room temperature, 0W20 flows more easily, but at engine operating temperature, around 200 degrees Fahrenheit, both oils reach their designed operating viscosity. The 20 and 30 numbers refer to high-temperature viscosity, not what you see at room temperature. Pour a quart of fresh 0W20 and a quart of heated oil from a running engine side by side, and you would see very different flow characteristics. The cold oil is designed to flow easily when the engine is cold. Once heated, it maintains film strength. Let's close in on this with some perspective on why this matters. Your vehicle is likely one of your most expensive possessions. Proper maintenance protects that investment. Using the correct oil is one of the most fundamental aspects of maintenance. It costs no more to use the right oil than the wrong oil. A 5-quart jug of 0W20 synthetic costs about the same as 5W30 synthetic. There is no financial penalty for doing it right. The penalty only comes when you do it wrong and face engine damage or denied warranty claims.